So we had just like started off a little bit last day, but uh, like a quick recap. So for the next 2-3 lectures, we will be mostly discussing about debiasing, word embeddings. Now, last day we have already motivated ourselves as to what is the requirement of generating word embeddings in the first place. What are the different types of NLP applications that like these word embeddings might be useful for? And we have also seen some of the inadvertent consequences of these word embeddings, like in the form of making certain gender neutral occupations highly stereotypical, and mm, thereby resulting in a lot of bias in the system. Okay, so in this paper, so the NeurIPS 2016 paper, the authors actually did two types of things. One was all about analysis of the biases present in the word embeddings. This was one part. This was one part of the study. While the other part was debiasing the biased word embeddings. Okay, so these were the two main objectives that they started off with. Now we will slowly, step by step, discuss each of these one by one. So in order to start off with, we need to get acquainted with a few basic definitions. Which we will consider for the rest of the analysis. Okay, so let's say W is a word. Okay, W vector is a unit vector, or in other words, an embedding. Okay, of the word W. Okay, and W vector is drawn from a real d-dimensional space. And as we are already notifying that W vector is a unit vector, therefore the norm is 1. Okay, so for each W, in a vocabulary capital W, we have a corresponding W vector in RD. Okay. Now there are a few. So these are like the general ones. There are a few specific ones required for this particular study. The first set of specific words are what we call the gender neutral words. Gender neutral words. Okay. Now let this set of words be N, which is subset of W. Okay. So for instance, these would be words like flight attendant, or shoes. Okay. Do not have any connection to gender. That's why they are called gender neutral words. Gender. Okay. Fine. Now the size of any set, we shall indicate it. So any set S, we shall indicate it by mod of S. Okay. Then we will have another set of female male gender pairs. Okay. This set is chosen from W cross W. Okay. So these are pairs. Like examples are she, he, mother, father, etc. Okay. So these are some of the gender pairs. Right. Now similarity. Between word vectors or embeddings. So similarity is measured simply by the inner product. Inner product of the vectors. Okay. So simply the inner product of the two word vectors, say W1 and W2, represents the similarity between the two words. Okay. So basically here we will use or abuse the terminologies a bit. In the sense that we will call the embedding of a word and the word, like, we will refer to them similarly. So they will be interchangeably used. The embedding or the vector of a word and the word itself will be interchangeably used. Okay. Now, that would mean that if we want to say that cat is more similar to dog than cow, we will say this as, can you tell me how? Can you tell me how we will express this? Since we now have representations for each of these words.
The dot product between the word embedding for cat and dog is more than cat and cow.
Yes, cat into dog, the inner product of cat into dog should be larger or equal to the inner product of cat into cow. Okay. And as you know, for any arbitrary vectors, the inner product is nothing but the cos of the cosine angle of the two vectors now. Since our word vectors are already normalized, they are unit vectors, so therefore it just boils down to the product of the two words. Okay, so the cos of w1 to w2 is just w1 into w2, because each of them are already unit vectors. Now, in order to do so these are the some of the basic definitions that we will have to refer to time and again when we go across this paper. Okay, so these were the basic definitions that we need to refer to. The next thing is embedding. So now, since we are dealing with embedding, we need to have a mechanism to generate the word embeddings. And the authors used, without any loss of generality, the authors used one specific form of embedding, but they also showed that their results hold for other forms of word embeddings also. So the authors in this paper used the 300 dimensional word embeddings generated from the W2V news corpus using the word to vec model. Okay, so this is a specific model that actually generates the word embeddings given a running corpora, and in this case the running corpora that the authors used is the Google W2V, sorry, the W2V news corpora. Okay, but they also used the Google News corpus, and that also actually gave very similar results. So now they started off with 50K words. Okay, most frequent. They started off with the most frequent 50K words. Then they did some pruning, some filtering. First filtering was only lowercase words were used. Less than 20 letter, except less than, not less than, equal to. Less than 20 letter words were used. Numbers, etc. were all discarded. Now, after applying all these filters, the final set of words on which the authors ran all their experiments was around 26K. Fine. So now, so this is the embedding part. So you see how things are developing. First are the basic definitions, then the embedding that they used. Now they need ground truth. As to what is a gender biased profession and what is not a gender biased profession and things like that. So this kind of ground truth they need. So for that they recruited AMT users, okay, for crowd experiments. Now what did they specifically do here? First of all, they restricted their AMT users to US based people only, because they were mostly doing experiments on the English dataset. So that's why they restricted their user base to the United States population only. Two types of data gathered. Okay. The first type was where they solicited words from the crowd. Okay. One place is where they solicited words from the crowd, and the other is where they solicited ratings by showing words to the crowds. Okay. So basically, this one was to see if embedding biases contain those that are also in the crowd. while the other one is trying to see if crowds biases contain those from the embedding. Okay, so two types of experiments they did. One was where they solicited words from the crowd. They asked the crowd that, okay, give us some words which you think are stereotypical. Okay, and the other one, they gave the crowd some words and asked them to rate those words as whether they are stereotypical or not. Okay, so for each word, 10 crowd judgments were taken. Okay, and majority decision meant that more than 5 or more co-worker okay, should vote for the decision. So this was how the crowd experiments were done. So you will see explicitly like where exactly the crowd experiments were used and how the authors tried to evaluate based on these crowd experiments. As we go ahead with the experiments, we will see how the authors actually used these crowd judgments and where exactly they use these crowd judgments in order to like make their evaluations. Okay, so the first thing, now we start with a first set of experiments. In the first experiment, the authors tried to evaluate whether the embedding has stereotypes stereotypes on occupation words. That was number one. And number two was evaluate whether the embedding whether the embedding produces analogies that are judged to reflect stereotypes of the humans. So the first one was to evaluate whether the embedding has stereotypes on occupation words, and the second one was specifically geared to study analogies. Okay, so let's see one by one. The first one, as we said, is occupational stereotypes. What did they find here? So they tried to find, like, they took the she, he vector. Okay, they took the she, he vector in order to find the occupational stereotype. Okay, they used the she, he vector, and we will see what exactly they did. Okay, but tell me one thing, why did they choose the she, he vector and not the woman, man vector? Why was this not used? As you can understand, this is a gender direction. The she, he axis is a gender axis. Similarly, woman is also a gender direction. But for their experiments, the authors chose this and not this. Why? Any idea why? Any thoughts? Why this could be the reason? This has connection to the usage of the words. That's a hint. No clue? Okay, let me ask you a slightly different question. How many meanings of this word do you know? What are
One
the different senses? Yeah, someone was telling something. Please go ahead.
as a meaning, there's just one.
One,
Yeah.
Sir, sometimes it refers to the human race as a whole.
very good. Yes. So one is man, as in the male gender. The second one is, as Hardik just now pointed out, it could refer to mankind. Okay. So therefore, while constructing the gender direction, we want to have such words which do not have multiple meanings. Okay, because that jeopardizes the structure of the gender direction. So for instance, if you consider she, he, since these are pronouns, they do not have any other meaning, any other additional meaning. So we want to avoid polysemous words. And in this case, man is a polysemous word because it has multiple senses in which it could be used. So therefore, the authors started off with the she, he gender direction in order to do their experiments. Okay, very good. Now, closest words to she and closest words to he. So they found some of the occupation words that are closest to she and that are closest to he. So you remember they had selected a set of occupation words N. Okay. So this was a list that they curated, and using this list, they tried to see the occupation words that are aligned toward she and the occupation words that are aligned toward he. Okay, so some of the examples that they found here are as follows. So these are some of the words that are closest to the she direction, and these are some of the words that are closest to the he direction. Okay, so what do you see from here? I will have two questions. One is your observations from this, and the second one is what do you mean by closest? First, let us go with the first one. What do you see from here? What are your observations as a lay person? So are these occupation words in general gender neutral, or are they gendered?
They're gender neutral.
They are all gender neutral. Okay, fine. So all these occupations, despite being gender neutral, they have strong, some of them have strong closeness with the she direction, and some of them have strong closeness with the he direction. Now, let us make a deeper observation as to like observing these two lists and trying to make some inference. Are you able to make some inference?
The words related to the words that are closer to he are more leadership and power oriented.
Excellent. Yeah. So these are like many of them are related to the power figure. For instance, as she pointed out, maestro, captain, boss. Okay. So these have a lot of power connotations with it. And for the he direction,
For she, it's more of a keeper, as in
more of a keeper, more of a keeper. Absolutely correct. Yeah. So this is more of a power portray. And for she, this is more like a keeper. Okay. So now tell me, how did they find this closest? This is a vector. This is a vector idea. What do you mean by closest? Now, she, he is a gender direction. And these words, each of these words are vectors. Now, what are they finding? What is the most common operation that you do on vectors? This will be required in the next class when we study debiasing. What is the most common operation?
Dot product.
Uh, Dot product is fine, but here what is going on?
we're
Some sort of dot
subtracting.
subtraction. Is subtraction the correct way to go about? On the he, she axis, you are doing something. On the she, he gender axis, you are doing something.
Linear combination or something like that, or distance maybe.
Projection.
Yes. So distance is a simple distance. That's what they're finding, right? Closest. What is the interpretation of closest? How distant they are. So they are finding the projection. Projection of each of the above word vectors on the which tells them the closeness. Okay, fine. So now this is what they observed. Okay, using their metric of projection, they found out that these are the words that are closest to the she um, uh, class, and these are the words that are closest to the he class. Okay, now they wanted to evaluate this list, and here is where the crowd workers come into play for the first time. So now what they are doing, they are giving each of these occupation words, give each of these close occupation word to 10 crowd workers. As I said, always they're evaluating each word with 10 workers. Okay, and now the workers had to tell whether the word reflects a gender stereotype or not. Okay, now since 10 people are doing, you have a rating from 0 to 10. Okay, I'm sorry. So uh, so let's step back once more. I think they did it in this way, that each each crowd worker will give an integer rating between 0 to 10, okay, indicating the extent of similar stereotypicality, extent of stereotypicality, extent of stereotypicality for each word. Okay, so now the point is that, like, having a stereotypicality larger than or equal to 5 is considered to be high stereotypical. Now this can be averaged over all the crowd workers, and an overall rating for a particular word can be obtained. So for every word, the rating of overall stereotypicality was obtained from the crowd workers. Okay, so this was the one side of it. The other side was the closeness value obtained using the projection scores. Now, with these two things on two sides, the authors went on to a simple Spearman's rank correlation. So for you rank by this rating uh, and you rank by this projection scores. You rank the words, occupation words, by ratings, and you also rank the occupation words by projection scores. And now you take a Spearman's rank correlation. And this comes out to be, for the set of occupation words that the authors were testing upon, for them, this came out to be 0.51. Okay, so try to understand once more. So let us clarify. On one side, you have ranked the same occupation words using the integer rating that you have obtained from the crowd workers. On the other side, you have uh, ranked the same set of occupation words based on the projection scores on the he/she gender direction. Okay. Now these two ranks you have with you, these two rank lists you have with you. Now you compute a simple Spearman's rank correlation, and the rank correlation comes out to be 0.51. So what is your observation? So a low value, high value, medium value? What do you think? No idea? Is this low? What is the range? What is the range? What is the range of correlation? Huh? In general, what is the range of correlation? Correlation values start from start and end
-1 to 1.
-1 to 1, and you are at 0.51. So what do you think? So experts would say that this is a very strong correlation. Okay, so given this is realistic data and given your other margin is at -1, this correlation value is very strong. So which means that the gender, which means that the occupation words are actually, as per the ratings of the crowd workers, are strongly biased, okay, or strongly gender stereotypical in nature. Fine. So that is what is coming up from this whole story. So you have the set of occupation words chosen. Now you uh, ask your crowd raters to tell like how stereotypical they find each of these, and then on the other side you make a computation using your embeddings, and then you try to find out a correlation. So basically what you are showing that the embeddings generated by these models actually have a strong stereotypicality in the representation of the occupation words. Okay, so this is the first exploratory analysis that the authors did. The second one was about analogies. So if you recall, last day only we discussed a little bit about what are analogies, right? So for instance, if you have and the last is a blank, then the closest answer is queen. Okay, so this is what is an analogy problem. And the analogy problem is actually required to be solved in many different downstream NLP applications. Okay, so here the authors try to solve an analogy problem which is slightly different from the general analogy, general specification of the analogy problem. So in a general specification of the analogy problem, 3 words are given and you are supposed to guess the 4th word. Now here the authors slightly modify the problem as follows. So what they want to do is they want to suppose the words she and he are given. They want to generate XY pairs of words. Okay, they want to generate XY pair of words such that he to X and she to Y is a good analogy. This is what is their objective. So the general objective of an analogy task is the following. So you have 3 words given and you want to guess the 4th word. However, for their purpose, the author slightly changed the problem definition and said that I am given a pair of words, okay, like she and he, and I want to generate all such XY pairs of words such that he to X and she to Y is a good analogy. And I want to score these analogies. Okay. So tomorrow's class, we will see how the authors went on and achieved scoring these analogies. We'll stop here. Any questions? Okay, there are no questions. We'll stop here.